Hello. Hello everyone. Hello everyone. Welcome to the course Material Characterization, which is being taught by Professor S. Shankaran from IIT Madras. The course ID is NOC 26mm43. This is the live problem solving session for week 1 of the course. I am Mayangal. I am a research scholar in the Department of Electrical Engineering, IIT Bombay. Now, this course is being taught by Professor S. Shankaran, who is an associate professor in the Department of Metallurgical and Materials Engineering at IIT Madras. The course plan for the first week is Fundamentals of Optics and Optical Microscope and its Instrumental Details. So, this live tutorial session is happening every Sunday 6 p.m. to 8 p.m. at this Google Meet link. So, what I will be doing in this course is I will be showing you some practice questions which will be similar to what you get in your assignments and maybe also in your exams. So let's start. Identify the correct statement which depicts the relation between E and lambda, where E is the energy of photon, lambda is wavelength. E increases when lambda increases. E increases when lambda decreases. No such correlation between E and lambda. So if you know the answer, you can speak it or you can write in the chat. Does anyone know the answer to this? That is correct. The answer is E increases when lambda decreases. So the formula is E equals to h nu. Formula for energy of photon is E equals to h nu, where h is Planck's constant and nu is the frequency of the photon. And frequency can also nu can also be written as c by lambda. So E can be written as hc by lambda. So if lambda decreases, then E increases. Which of the following statement is not correct? Speed of light will change when passing from one medium to another and is called Snell's law. When light passing from higher density medium to low density medium, its velocity will increase. When light passing from high density medium to low density medium, its velocity will decrease. Which of these is not correct? Anyone? So the answer to this is when light passing from a high density medium to low density medium, its velocity will decrease. So the velocity of light is inversely proportional to the inversely proportional to the density of the medium, and that is why the speed of light velocity of light is highest in vacuum. Which of the following have highest resolution? Human eye, optical microscope, glass lens. That is correct. The answer is optical microscope. So optical microscope has an resolution in microns, whereas human eye cannot go that below. Op- Optical microscope can go submicron in nanometers. The range of position for an object in which image sharpness does not change is called depth of field, focal length, resolution, depth of focus. That is correct. It is called depth of field. So depth of field is the range of the position of the object which we can move and still see a sharp image. Focal length is a measure of the lens. Resolution is a measure of how much distance we can resolve, and depth of focus is the range of movement in the image plane where the where an image sharpness is maintained. Best possible resolution of optical microscope is about zero point 0.1 micron, zero point 0.2 micron, zero point 0.3 micron, zero point 0.4 micron. That is correct. The answer would be A, zero point 0.1 micron. So below that you below that you are not able to resolve using visible light because for resolving you need the the distance to be in the order of the wavelength. Next question: which of the following conditions required necessary for collimated waves? Coaxial paths of propagation through space, same wavelength, same phase, same state of polarization. That is correct. The answer to be A. Collimated waves propagate in the same direction, that is without convergence or divergence, but not necessarily having the same wavelength, phase, or state of polarization. So if it has same wavelength, it will be called a monochromatic light. If it is collimated and also has same phase, then it can be called coherent light, coherent waves. Or if all of them have same state of polarization, then they will be just polarized waves. In light microscope, the ray subtending angle on the dry objective lens is 39 degrees. We want to increase the resolution of microscope. Which of the following option is best suitable? Decreasing the wavelength, increasing the light subtending angle to 50 degrees, medium between objective lens and specimen filled with oil, decrease the light subtending angle. That is correct. The answer to be C. For dry lens, numerical aperture is limited because ray subtending angle greater than 41 degrees cause total internal reflection and never enter the lens. So you are limited by this. So you cannot increase the light subtending angle. Decreasing it will reduce your resolution. So the best option is to add a medium between objective lens and specimen of oil, so as to increase optical. So numerical aperture is n sine theta. So theta you cannot increase more, so you can increase n. You can also decrease the wavelength, but generally in microscopes we don't use monochromatic light, we use polychromatic light to view. So wavelength decrease is not real necessarily an option every time. For a yellow light, that is monochromatic, lambda equals to 580 nanometer source optical microscope having medium between objective lens and specimen filled with cedar wood oil, which has n equals to 1.5 and subtending angle is 39 degrees. Find the depth of field. 0.976 nanometer, 0.976 mm, 0.976 micrometer, 9.76 micrometer. That is correct. The answer would be 0.976 microns. So you are given n equals to 1.5, lambda equals to 550 nanometer, and alpha equals to 39 degrees. So you can calculate numerical aperture n sin alpha, which comes out to be 0.943. And to calculate depth of field, the equation is n lambda by na square. If you put all these values here, you will get your depth of field equals to 0.976 microns. Uh, Which of the lens defect occur when light is not monochromatic? Spherical aberration, chromatic aberration, comma, astigmatism. That is correct. The answer would be B, chromatic aberration. So what is chromatic aberration? It is basically so yes. So this PPT this PPT will be uploaded and you can find it on the web page. This will be uploaded in a Google Drive. So chromatic aberration. So basically, for the for each wavelength of light, the Snell's law acts differently, and hence it the focal length of the lens for each wavelength of light will be different. So there will be some variation in the of the focus point for each wavelength. So each wavelength will have a slightly different focus point, and that is called chromatic aberration. For an optical microscope, the focal length of objective lens is 40 mm, focal length of eyepiece is 10 mm, and the optical tube length is 200 mm. Find the total magnification if distance of distinct vision is 100 mm. 10x, 20x, 40x, 50x. That is correct. The answer will be 50x. So you are given T equals to 200 mm, D equals to 100 mm, F of objective equals to 40 mm, and F of eyepiece equals to 10 mm. So you can the total magnification will be magnification of objective into magnification of eyepiece. So that will be T by FO into D by FE, which which if you put together you will get 50x. Calculate the optical path length difference for this for this you have a you have a light propagating, and in the middle you have put a block of higher optical density. So what will be the path length difference that this will create? 0.255 micron, 0.343 micron, 0.343 mm, 0.255 mm. That is correct. The answer would be 0.255 microns. So when you so when you put a higher optical density object in the optical path length, what will happen is that the light traveling through that medium will slow down, and hence it will create a path length difference, which is defined as the product of thickness T of the medium and refractive index and difference, such that delta equals to n1 minus n2 into T, which would be 1.5 minus 1.33 into thickness, which is 1.5 microns. So the product will come out to be 0.255 microns. Tell the name of the defect where the image plane is not flat but it has concave spherical surfaces as seen from the objective. Astigmatism, curvature of field, spherical aberration, chromatic aberration. So the answer to this is actually curvature of field. So curvature of field is a series of axis aberration. Field curvature indicates that the image plane is not flat, but it has the shape of a concave spherical surface as seen from the objective. Different zones of the image can be brought into focus, but the whole image cannot be focused simultaneously on a flat surface as would be required for photography. Field curvature is corrected by the design of objective and additionally by the tube or relay lens and sometimes the oculars. So if you so curvature of field happens when you look into the image and it is not it is it's and you suppose it to be flat but it is not flat but curved image, and that curvature is coming due to the curvature of the high curvature of the objective. So it is sometimes called as fisheye effect. In aberration in spherical aberration different so different points on the objective have different focal lengths, so they don't always focus on one point, and hence different parts of the objective will in focus, and randomly there will be portions of the image of the object that will be in focus and other will not be in focus, and non there won't be any clear focal point. Which of the following statement is wrong about spherical aberration? Caused due to spherical surface of lens. It can be corrected by use of converging and diverging lens of different refractive index. It is zero when object distance is nr, where r is the radius of curvature of spherical lens. It is an off-axis aberration. That is correct. It is an off-axis aberration. So astigmat it is so it is not an off-axis aberration. Astigmatism, curvature of field, and comma are off-axis aberrations. That is, these aberrations are not visible when the objective is directly on axis. They are only observed when the objective is not on the axis. But spherical aberration is observed also on axis. To form an image, the minimum number of diffracted beam required to enter in objective lens 2, 3, 4, 1. That is correct. The answer is A. So according to Abbe's criterion, in order to form the image of an object, at least two diffracted beams should enter in objective lens. So the meeting point of these two beams will be defined as the image point. So a single beam cannot form an image, at least two is required. Find Na and resolution limit of light having a wavelength of 700 nanometer in pure water, that is n equals to 1.33 at cone angle 70 degrees, 0.763 and 560 nanometer, 0.736 and 560 micron, 0.763 and 650 nanometer, 0.7360 and 650 micron. That is correct. The answer to A. So the numerical aperture is calculated as mu sine alpha. So cone angle is 2 alpha, that is 70 degrees. So alpha would be 35 degrees. So Na can be calculated as mu sine alpha, that is 1.33 into sine 35 degrees, which comes out to be 0.763. Now the limit of resolution is calculated as d equals to 0.61 lambda by Na. So you put that 0.61 into 0.61 into 700 divided by 0.763. So that will come out to be around 5 560 nanometers. For an optical microscope, the focal length of objective lens is 40 mm, focal length of eyepiece is 10 mm, and the total magnification is 50x. Find the optical tube length if the distance of distinct vision is 100 mm. 100 nanometer, 100 mm, 200 nm, 200 mm. That is correct. The answer is D. So again, it's a variation of the earlier question. So you have given total magnification 50x, uh, distance of distinction is 100 mm, objective focal length is 40 mm, eyepiece focal length is 10 mm. So again, it will be total magnification is objective magnification into eyepiece magnification, which is given as objective tube length divided by objective focal length, and distance of distinct vision divided by eye, eyepiece focal length. So you rearrange it, you will get T equals to 200 mm. What is the total magnification when using a microscope with an eyepiece lens magnification of 10x and an objective lens magnification of 50x? 500x, 100x, 50x, 1000x. That is correct. The answer to be A, 500x. So total magnification is equal to the multiplication of magnification of eyepiece lens by magnification of objective lens. That is 10x into 50x. That would be 500x. For a yellow light monochromatic lambda equals to 550 nanometer source optical microscope having medium between objective lens and specimen filled with cedar wood oil, n equals to 1.5, and depth of field equals to 0.976 micron. Find the numerical aperture and subtending angle. 0.967, 29 degrees, 0.943, 39 degrees, 0.934, 39 degrees, 0.976, 29 degrees. That is correct. The answer would be B. So you are given n equals to 1.5, lambda equals to 550 nanometer, or 0.58 nanometer microns, and depth of field equals to 0.976 microns. So we know the formulas: depth of field Z equals to n lambda by na square. So you put all the values, you calculate na, it comes out to 0.943, and then we know na equals to n into sine alpha. So we know na and n now, so we can calculate sine alpha and then alpha, which is comes out to be around 39 degrees. Resolving power of an instrument can be increased by using an illumination of longer wavelength and by decreasing the Na. Using an illumination of longer wavelength and increasing the Na. Using an illumination of shorter wavelength and increasing the Na. Using an illumination of shorter wavelength and decreasing the Na. That is correct. The answer is C. So the formula for resolving power is Na by lam- is proportional to Na by lambda. So resolving power is inverse of limit of resolution. So limit of resolution is given as 0.61 into lambda by Na. So this would be inverse of that. So so hence if you increase Na or if you decrease wavelength, that is decrease lambda, your resolving power will increase. Which of the following statements is not true? When focusing the slide, care should be taken not to crack the glass slide. The slide should be placed on the stage with the cover slip on the upper surface. When setting up, adjust the eyepieces to the dimensions of your eyes. Always view your specimen using the highest magnification lens first. That is correct. So you should always start viewing your specimen with the lowest magnification, and there are mainly two reasons for that. One is that if you start with highest magnification, it will be very difficult to locate your sample, because initially you won't know if your sample is directly under the microscope or not, and the region of interest is under the microscope or not. Secondly, the working distance or the working distance and your depth of field are both very small for highest magnification lenses. So there is a chance that you will hit your you will hit the specimen with the lens, which will damage both your lens and your specimen. And also you will your since the depth of field is very small, it will be very difficult to get your object in focus if you don't know where the your focus currently is. You place a specimen under the microscope and notice that parts of the specimen begin to emit light immediately. These materials can be described as fluorescent, transparent, opaque, phosphorescent. Mhm. So the answer to this is actually A, fluorescent. So transparent means you can see through the object. Opaque means you cannot see through an object. Both fluorescent and phosphorescent means that the object is emitting light when you shine light on it. But the difference is that fluorescence is immediate. That is, as soon as you shine light on your specimen, it will also start emitting light, and it also stops immediately. So as soon as you stop shining light on the specimen, within few seconds or milliseconds, it will stop emitting light. That is called fluorescent. In phosphorescent, this process is delayed. So when you start shining light, your specimen starts charging up. It does not start emitting light immediately. It charges up, and and slowly it starts emitting light. And when you stop shining light on it, it will still continue emitting light for a very long time. This concept is used in glow in the dark objects, where during the daylight or during light, these sticker glow in the dark stickers start charging, and when there is dark, they start glowing and they keep glowing for a long time. Which of the following has the highest energy? Light with a long wavelength, light with an intermediate wavelength, light with a short wavelength. It is impossible to tell from the information given. Mhm. That is correct. Light with a short wavelength will have the highest energy because energy is inversely proportional to lambda. So lower the lambda, higher the energy. So this is a similar question to previous one. Calculate the optical path length difference 0.255 micron, 0.343 micron, 0.343 mm, 0.255 mm. So that is correct. The answer would be 0.343 mm. So just like last time, the path length difference with delta would be n1 minus n2 into t. So this time thickness is 2.02 microns. So you do 1.5 minus 1.33 into 2.02 micron, and you will get delta equals to 0.343 microns. Calculate the position of the image and its magnification when an object is held 10 centimeter from a convex lens of focal length 8 centimeter, 20 centimeter from length and magnification is 2, 20 centimeter from length and magnification is 4, 40 centimeter from length and magnification is 4, 40 centimeter from length and magnification is 2. That is correct. The answer would be C. So to calculate position of the image, we will use the formula 1 by f equals to 1 by u plus 1 by v. That will come out to, that will, you put 1 by 8 and 1 by 10, the v will come out to be 40 centimeter. And then magnification can be calculated by f divided by u minus f, or you can also do v by u. That will give you m equals to 4. So that is all the questions I had for today. Thank you for joining. If you have any doubts, you can ask in the chat or by speaking. The PPT and the PPT will be shared in some time. You can you can get the link through your NPTEL portal. So next tutorial session will be next week. So tomorrow there will be another tutorial session which will be conducted by a different person. I will recommend you also join that tutorial. You will get extra knowledge.
Jelas kalau dalam